All right, we're back for video number 2. Shifting to the next page of notes. I'm going to bounce around on this page because it covers kind of a combo of everything we just did before I dive into part 2 of the lesson. So, questions 1, 2, and 3, find the distance between the 2 points. I don't think I'm going to do that one. I think you can practice using the distance formula. Find the slope of the given line. I just want to remind you, slope, you just need 2 points. So since they went ahead and kind of put those dots on there, let's just use those. This is the coordinate 0, 2, and this is the coordinate 1, 2, 3, 4, 6, 3. And once you have your 2 points, this is your first x and your first y. This is your second x and your second y. And now you can officially, find the distance between your y values and divide it by the distance in your x values and find the slope. Midpoint, same thing. I think you can use the midpoint formula to find that. Sketch the lines. Just a reminder, the origin is the point 0, 0, and they just want you to practice drawing lines with certain slopes. I'll just pick one randomly to show you, let's do a negative one. Let's do number 4. Passes through the origin, okay, with a slope of negative 4. So if the slope is negative 4, that's technically negative 4 over 1. Okay, the number on the top is always how much you go up and down, and the number on the bottom is how much you go left and right, and you always go to the right. So if you want a negative line, you're going to go down 4, so 1, 2, 3, 4 over 1. Because if you went to the left, it would create a positive line, right? So we're going to go there, but we probably want to continue it. That was a bad one. Let's go 1, 2, 3, 4, more like that. Right. So there's our line. Down here are the 4 points that they gave you. You should plot all of those. And when it says what is the measure of the length of the rectangle and the width of the rectangle, I'm going to go ahead and spoiler alert. It's going to be diagonal, kind of like this, so that you can't just count. You're going to have to use the distance formula to find the lengths. And then you can find the perimeter and the area. A little flashback to geometry. I want to focus my attention on this part for video number 2, linear equations. We're going to talk about linear equations this semester. We're going to talk about quadratic equations. We're going to talk about exponential equations and logarithmic equations. We're going to look into conics at different shapes like ellipses and hyperbolas and parabolas. And you got to be familiar with the basics of a linear equation. So I hope you're able to review and kind of push yourself a little bit to really grasp these concepts more than just at the memorization level. Slope-intercept form. So we're going to look at 2 forms. Form number 1, slope-intercept. Form number 2, point-slope. And I want you to realize what these are. Both of them represent equations of a line. It's how we can model a line, a linear equation. Slope-intercept form is y equals mx plus b. And it's most useful for graphing. Because if you remember, the m value is the slope. That's the rise over the run. That's the steepness of the line, right? And this b value is your y-intercept, where your graph crosses through the y-axis. And if you know the slope and the y-intercept, then you can model your equation with a line. What are the x and the y? Those are going to stay variables. So like y equals 2x plus 3. Like that's an example. The slope and the intercept are always going to have numbers there. The x and the y, those are your 2 variables. X is your independent variable, y is your dependent variable. And slope-intercept form is useful for graphing. For example, we already have a line graphed here, so let's just look at that. Let's find our y-intercept. That's 1, 2, 3. So the y-intercept, I'm just going to use some shorthand here, is at 0, negative 3. And let's count our slope. Let's just count up our rise over run. So to get from this point to that point, looks like it went up 2 over 1. I think it's freaking small. Sorry about that. Up 2 over 1. I know the line's slightly off, but we're going to assume that that's up 2 over 1. I'll give you a clearer picture later. So then the slope is up 2 over 1. So that's a slope of 2. So then if we know this, we got the slope, we got the y-intercept, which is right there, the negative 3, and we can create this equation. Y equals 2x minus 3. Look at that, I almost predicted the future. I just made that up off the top of my head. I almost did the same one. You don't even know how lucky you guys are to have me as your math teacher. I could see the future. So that's slope-intercept form. It's good for graphing. Strongly recommend you use it for graphing. Point slope form, though, is the underrated, unsung hero. It is so useful when it comes to writing equations. Like creating, what? I cannot spell. Writing equations. I used to, for so long in my math career, I tried to make an equation, like on a real world problem from like the ACT, SAT. They're talking about, you know, like so-and-so, when they sold 2 bracelets, they made $12, and when they sold 12 bracelets, they had made $58, write an equation, etc. I was trying to use y equals mx plus b to write my equations. But I want you to know that when you need to make an equation to model a situation, point slope is money. And what point slope is it's y minus your y value of a point equals your slope times x minus an x value. So notice, we've got a y1, which is your y value, we've got an x1, which is your x value, and we've got your slope, along with the x and the y that doesn't change. Okay, that is point slope. Why is it called point slope? Because you have a point, which is your x1 and your y1, and you've got your slope, which is m. You with me? So if we wanted to use this example that I just made up to the right, I hope it doesn't come out as a fraction, but if it does, that's okay. We're big boys, big girls now. We can do fractions. So let's see. We got, that's my first coordinate. This is my second coordinate. I need to make an equation for this. So I've got coordinates, but what I don't have is a slope. If only last video Smith had given me the formula for a slope. Oh wait, he did. So we can say y2 minus y1 over x2 minus x1. 58 minus 12, 58 minus 10 is 48, minus 2 more is 46, over 10, darn. We'll just say, do I want to go decimal, 4.6, or do I want to reduce? We'll just reduce, and it'll be awkward, but what is that going to end up being? 22 over 5, if we divide both of the 23 over 5? Yeah, sorry, but here's our slope. It's an ugly one. So check this out. We need to make an equation for this line. We've got our point, boom, this one up here. We've got our slope. So our equation would be y minus our y value equals our slope times x minus our x value. There's our equation of the hypothetical scenario that I just made up. It's really nice. Point slope is really nice when you got to make an equation. And slope-intercept form is really nice when you have to graph. So let's take that into some examples here. Using the lines on the graph, list the lines in order from least slope to greatest slope. Okay, that's easy. The least slope is going to be the negative one, so that's going to be L3. It's going down, so it's the lowest slope. So we'll put L3 first. And then which one of these looks the flattest? It looks like L2 is the second lowest slope, because I'd say L1 is slightly steeper. And then L4 is obviously the steepest. So that's just kind of eyeballing some slopes there. What's the equation of L2? All right, now we're talking. Well, what do we need for an equation? We need a point, which they gave us. Ding, 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 ding. And we need a slope. And I got to be real with you. It looks like that's a flat line to me. So it looks like that's a slope of 0. Review from last video. So if there's a slope of 0, check this out. Y minus our y value equals our slope, which in this case is 0, x minus our x value, which is 3. And that's ugly, but what's 0 times anything? It's 0, so this ends up turning into this. And then we add the 4 over, and it turns into, hey, y equals 4. It's the equation for a horizontal line. There's just another proof of why that turns out like that. Okay, that's the equation for, we did number 1, we did number 2. I'm going to let you find the equation for L4, because I'm going to go ahead and tell you. We've got a point here. We've got a point here. That should be enough for you to find your equation. If you have 2 points, you should be able to find the slope, and then you could use either of those points to create your point-slope equation. Or if you want to get cute, you can count 1, 2, 3, 4, and then that's the rise, and then 1, 2, that's the run. But let me tell you, students rely on this too much. And I know you're like, but it's easy, Mr. Smith. Yeah, it's easy because we're doing elementary level numbers. But what if you're on a coordinate plane that's modeling your business supply and demand profit, and you're having to count, you're going to literally count thousands of little tick marks? I don't think so. Okay, so I do not recommend counting rise over run. I strongly recommend you subtracting y2 minus y1 over x2 minus x1 and using the formula. Okay, and what is the equation of L3? And they want it in both point slope and slope intercept. I'll just say this, like, let me just make up one. This is not number 4. I just want you to see. If we had something like this, and I told you to convert that into slope-intercept form, it is just a simple distributive property on this side, and then add the 2 over to the right. Right? Sorry, I'm writing this and I'm listening. I think my neighbor is yelling at her dog. So just so you know, this right here is the exact same thing as this. It's just the first one is in point slope form and the second one is in slope intercept form. So if you want to do a quick back and forth, you can. Okay. All right, so let's build off of what we're doing. I'm going to do, let me see. Yeah, this will be the last page for this video, and then I'll just do maybe one more bonus vid because I'm rolling. And this is gold. Sketch the graph of the line on the axis provided. Looks like it's already there. I don't know what the heck that question is saying, but we could confirm. And one of the most useful skills that you need in dealing with lines is you need to be able to change this into slope-intercept form. This is called standard form. When it's 2x minus 3y equals 12. Like, standard form is one that we don't even talk about that much. That's it. That's called standard form, because I honestly recommend you to change it to slope-intercept. So how would we do it? We would need to subtract the 2x over. So it would be negative 3y equals negative 2x plus 12. And then we need to divide by that coefficient in the front of the y so that we can get it into y equals form. So when we do that, we'd have y equals negative 2 divided by negative 3 would be positive. 12 divided by negative 3 would be this. So let's see if this is correct. 1, 2, 3, 4. Yep, started at negative 4. We can check that off. And is the slope 2/3? Up 2 over 1, 2, 3. Up 2 over 1, 2, 3. Yep. So that is correct. I know the example tells you to sketch it. Looks like I already sketched it, so we'll just confirm. All right. I love question number 6. It really tests if you know this stuff or not. So I encourage you, if you feel like you're cruising right now, I encourage you to pause this video, do number 6 and 7 by yourself, and see what you think. But if you're struggling, if you had a long winter break, then and need a little help, then I got 1 minute to help you here. Find the equation of the line that passes through. It passes through this point with this slope. Okay, we've got a point, we've got a slope. Ding, 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 ding. Don't try to do slope-intercept. It's too hard. Do literally point slope. So y minus y1 equals slope times x minus x1. Voila. And when you see a minus, you can just make that a plus. Booyah. There's my equation. Part B. Write an equation of a line that passes through this point and is parallel to this line. Oh, snap. They gave me a point, but they didn't give me a slope. Yes, they did, because they want it to be parallel to that line, which means same slope. So once again, you have a point and a slope. Number 3, they want it to go through this point and be perpendicular to this line. We should know what that slope is from video 1. And then lastly, they want it to pass through this point and be parallel to the, we'll say that's y-axis. Parallel to the y-axis. That's a vertical line. We should know how to write the equation of a vertical line as well. Final video coming up next.